On July 29, 2025, the Earth flinched, and the consequences rippled across the entire planet. A magnitude 8.8 earthquake detonated just off the coast of Russia's Kamchatka Peninsula, and this wasn't your average seismic shakeup. It was one of those rare, colossal quakes that not only rattled buildings and stirred tsunami waves across the Pacific, but quietly rewrote aspects of the planet's own behavior. Yes, this one event was powerful enough to alter Earth's rotation, shift its figure axis, and even shave microseconds off the length of our days. If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next, and you being here keeps the conversation going. Thanks for watching. See you in the next one. It was a reminder that beneath our steady routines and familiar skies, the planet itself is still very much in motion, and it's not waiting for us to catch up. Now here's the wild part. Despite the massive magnitude, Kamchatka didn't suffer the kind of devastation you'd expect. That's thanks to tight construction standards, early warning systems, and an efficient evacuation effort that relocated over 2,700 residents in time. No deaths, minimal injuries. In the face of an 8.8 quake, that's almost unheard of. But while the surface damage was contained, the real story was unfolding deep within the Earth and high above it. In the aftermath, scientists detected that Earth's rotation had subtly sped up. Atomic clocks and satellites confirmed it. Our days are now shorter by a few microseconds. Not enough to mess with your morning alarm, but absolutely enough to show up on precision instruments. That shift in spin, it wasn't random. When such a massive chunk of the crust displaces, Earth's mass distribution changes, and that changes how the planet spins. It's the same principle as a figure skater pulling in their arms to spin faster. That wasn't all. The quake also shifted the planet's figure axis, which is different from the axial tilt you learned about in school. The figure axis is essentially where the Earth's mass is balanced. During this quake, parts of southern Kamchatka physically moved up to 2 meters southeast. That's a continental level shove. The axis shift was comparable to what happened during the 2011 Tohoku earthquake in Japan and the 2010 quake in Chile, both of which also caused measurable changes in Earth's rotation and mass distribution. Now, before you start picturing the planet wobbling out of control, let's clarify. Earth's axial tilt, the one that gives us seasons, is still holding steady at around 23.4 degrees. That didn't budge. What shifted was the internal distribution of mass, not the angle of our orbit. Still, even small changes to the figure axis can have long-term implications for how the Earth behaves over time, especially when stacked on top of one another. And here's where things get even more complicated. As groundbreaking as this seismic event was, it's not acting alone. Scientists are now looking at another surprising player in the game of planetary stability: us. Human activity, specifically large-scale groundwater extraction, has been shifting Earth's mass more significantly than some earthquakes. Since the 1990s, pumping water from underground reservoirs has slowly but steadily redistributed enough mass to nudge the figure axis. It's not just a climate issue or a water crisis, it's planetary physics. When you combine natural tectonic forces with human-induced mass movement, the results are subtle but real. Earth's moment of inertia changes. Its spin adjusts. Its internal equilibrium recalibrates. And while it's not causing dramatic tilts or sending us into a new orbit, it is revealing just how sensitive our planet is to what happens both underfoot and above ground. The Kamchatka quake gave scientists a rare opportunity to watch these mechanisms in real time. Satellite systems, ocean buoys, atomic clocks, and seismic networks were all tuned in, capturing the event as it unfolded and documenting how the planet responded. From the instantaneous crustal shifts to the slightly faster rotation, this one quake became a kind of geophysical masterclass. And the results? Earth held its ground literally and figuratively. The systems that keep our planet balanced adjusted, reoriented, and returned to a stable state. In other words, Earth shook, flexed, and carried on. But it's not just about resilience. It's about awareness. Events like this show us that the ground we walk on isn't as unchanging as we like to think. We're living on a dynamic system that responds to every stress, natural or man-made. Whether it's a tectonic plate slipping 9 meters in a matter of seconds or billions of gallons of groundwater being pumped from the soil, the effects register. They add up. And sometimes, they show up in places we'd least expect, like the ticking of a clock or the balance of Earth's spin. It also raises the stakes on how we prepare. The limited damage in Kamchatka wasn't luck, it was infrastructure, protocols, and early warning systems doing exactly what they were designed to do. If you enjoyed this breakdown, don't forget to like, subscribe, and drop a comment. Your feedback helps shape what we cover next. And you being here keeps the conversation going. Thanks for watching. See you in the next one. The data from this event will help refine those tools even further, from predictive quake modeling to future tsunami responses. And the more we learn, the better equipped we are to stay ahead of the next one. At its core, this earthquake reminds us that Earth is not a passive stage for our lives. It's an active, living system, constantly evolving under the weight of its own forces and increasingly, ours too. What might feel like minor shifts, a 2-meter bump here, a microsecond loss there, are part of a broader, invisible dance that's been going on for billions of years. We're just finally starting to see it clearly. And that clarity? It's coming from some of the most advanced monitoring systems ever built. We're talking satellite constellations capable of detecting millimeter-level movements, seismic networks, listening to the Earth's every creak and groan, and atomic clocks so precise they make your smartphone look like a sundial. Thanks to them, we now know when the Earth speeds up, when it rebalances, when it readjusts. And with every quake, every subtle shift, we understand a little more about what keeps this planet spinning. That's the real takeaway. Even as Earth resets itself from a colossal 8.8 earthquake, its deeper balance stays intact. Not because it's immune to change, but because it adapts. Just like it always has. From the tectonic roars to the silent slips, from natural upheaval to human-driven redistribution, the planet continues to find its rhythm. So the next time the ground feels solid beneath your feet, remember, it's only solid because it's constantly in motion. Like the video. If this shook you even a little, drop a comment with your thoughts on how human activity might be changing Earth more than we realize. And if you want to stay on top of the drama, beneath the crust and everything above it, hit that subscribe button. You won't want to miss what's next. You'd think a planet tilting, spinning faster, and shifting its own mass by meters would make bigger headlines. But no, between celebrity breakups and whatever TikTok drama is dominating that day, this earthquake barely dented the news cycle. Meanwhile, our literal planet is over here readjusting its balance like it just rolled an ankle. Let's talk about the real implications. A quake of this magnitude 8.8 on the Richter scale isn't just massive, it's in the top tier of seismic events. This isn't a once-a-decade situation. This is once every several decades catastrophic energy release. And the Kamchatka quake wasn't buried deep in the crust, where it could be cushioned and muffled. It happened at just 20 kilometers down, which is considered shallow in geological terms. That makes the shaking more intense, more violent, more likely to cause surface destruction. Yet, no mass casualties, no flattened cities. Why? Because Kamchatka took the threat seriously before the quake even struck. Their evacuation plan was fast and disciplined. Their buildings, built to resist the kind of force that would turn others into rubble. It was textbook preparedness. And frankly, it's a bit embarrassing how rare that is. But this isn't just a disaster story with a happy ending. What happened under the surface tells a much bigger, more unsettling tale. After the shaking stopped, and the tsunami alerts began to fade, scientists got to work. Using an intricate network of global satellites, seismographs, and the most precise atomic clocks on Earth, they pieced together what had actually changed. And it turns out, it wasn't just the coastlines. It was the entire planet's rhythm. They measured Earth's rotation and found that it had sped up. Just a little. Just a few microseconds faster per day. But think about that. An earthquake so powerful, so massive, that it literally made the world spin faster. This isn't science fiction. This is measurable physics. And while microseconds don't seem like much, they speak volumes about the amount of energy released and how the planet reacts to extreme forces. The quake didn't just adjust our rotation, it also changed Earth's figure axis. That's not the same as the rotational axis, which gives us our seasons and orbits us through space, like clockwork. The figure axis is more subtle, it's about how mass is distributed throughout the planet. Think of it like a spinning top. If you shift weight from one side to another, even slightly, the top will start to wobble or reorient. That's what happened. The mass redistribution caused by the Kamchatka quake moved Earth's figure axis, with parts of Kamchatka itself sliding nearly 2 meters southeast. And here's what makes that even more intense. This level of shift is on par with two of the biggest seismic events in recent memory: Japan's 2011 Tohoku quake and Chile's 2010 quake. Both of those were planet-altering. This one quietly joined their ranks. A cosmic nudge. A reminder that beneath the calm, the Earth is always adjusting. But here's where the conversation turns from natural disaster to existential reflection. Because it turns out the Kamchatka quake, as massive as it was, isn't the only thing shoving the planet's balance around. Humans, yes, us have been doing the same thing. Not with explosives or giant machines, but with something seemingly harmless: water. Since the 1990s, humans have extracted such vast amounts of groundwater from beneath Earth's surface that it's shifted the mass of the entire planet. Think about that. Water pulled up to irrigate crops, supply cities, or fill reservoirs doesn't stay where it started. It evaporates, flows elsewhere. There's different parts of the water cycle. That change in mass distribution has affected the figure axis more than some earthquakes. We have literally nudged the planet off balance, not metaphorically, not environmentally, physically. This is one of those moments where science sounds like satire. We're so good at moving stuff around that we've unintentionally altered how Earth spins, and we didn't even notice. So when a natural event like the Kamchatka quake comes along, and scientists say, hey, this massive tectonic rupture was actually less disruptive to Earth's axis than decades of pumping groundwater, that's the kind of fact that deserves a collective pause. Because while earthquakes are dramatic and unpredictable, human activity is steady, consistent, and cumulatively more impactful than we like to admit. It's also a reminder that our perception of stability is, well, delusional. And all this drama unfolded without most of the world even noticing. That's the irony. A literal planetary adjustment happened beneath our feet, and unless you were tuned into a seismologist's Twitter feed or a buried science report, you probably missed it. Because unlike a volcanic eruption or a hurricane, this kind of event doesn't scream. It whispers through datasets. It reveals itself through satellite drift and nanosecond loss. But resilience doesn't mean indestructibility. It's a balance, a constant recalibration. Earth isn't standing still, it's always adjusting, always responding. And the more we understand that, the more we realize how interconnected everything really is. Not just the plates and the oceans, but the atmosphere, the hydrosphere, and yes, even us. We're part of this system. We're moving its pieces, often without realizing. And in the case of Kamchatka, the data collected is now becoming a goldmine. Every seismic sensor, satellite pass, and atomic clock tick contributes to a growing body of knowledge that helps predict, model, and prepare for future events. It's one of the few times where the science is not just fascinating, it's actionable. That knowledge might be what saves lives the next time the plates slip. Because make no mistake, there will be a next time. Earth isn't done moving. Quakes like this don't reset the planet, they reveal it. They pull back the curtain on just how intricate and finely tuned the system really is. And maybe that's the bigger message here. Not fear, not doom, but awareness. That this world we live on, this supposedly steady sphere, is in constant, silent flux. It's always reshaping itself, always balancing forces. And sometimes, in a flash, it reminds us that stability is a process, not a guarantee. So if you've ever felt like time is moving faster, or like the days are blurring, well, technically, you're right. Thanks to the Kamchatka quake, they are slightly shorter now, and somewhere, the Earth keeps spinning. slightly faster, slightly rebalanced, still holding us up, even as it quietly adjusts to everything we throw at it, whether it's tectonic force or irrigation systems. We're talking atomic clocks so accurate they can detect a change of just 1/1000th of a second. That's what picked up Earth's new, slightly faster spin. We wouldn't feel it. We couldn't possibly notice it. But it happened, and it was real. A permanent, measurable consequence of tectonic stress, violently snapping loose off the coast of Kamchatka. But even more impressive is how Earth handled it. The crust broke, sure. There were shifts, but there was no collapse, no chain reaction, no planetary meltdown. Instead, Earth redistributed mass internally, adjusted its spin, and kept going. That's resilience on a scale we rarely appreciate. And here's the part that really sticks. It's not just natural disasters that push the planet into these rebalancing acts. It's us too. Our systems, our industries, our resource demands. That groundwater pumping we mentioned earlier, it's still happening, still shifting Earth's internal mass more than many quakes do. The Kamchatka quake may have grabbed attention with its raw power, but the slow, persistent weight of human impact is just as disruptive, just quieter. And that changes how we think about these events. Because if we can affect Earth's axis with irrigation alone, what else are we nudging without realizing? If tectonic energy and human industry are both moving pieces of the same system, then we're not just living on this planet, we're interacting with it, shaping it, influencing how it functions on a physical level. That doesn't mean we're doomed, but it does mean we have a responsibility to understand what we're part of. The Kamchatka earthquake didn't just prove that Earth is dynamic, it proved that Earth is responsive, sensitive to inputs, capable of both catastrophic movement and delicate recalibration. So next time you look at a calm sky or feel solid ground beneath your feet, just remember, it's calm because Earth lets it be. And it's solid until it's not. Hit that like button if you've gained a whole new respect for what's happening under the surface. Drop a comment with your take. Are we underestimating the role humans play in all of this? And subscribe if you want more no-nonsense breakdowns of the planet's wildest, quietest chaos. Because as long as the Earth keeps moving, we'll be here talking about it.